this is Dave Michaels, and I'm joined today with a colleague and industry expert and wireless expert, Michael Finneran. Hello, Michael.
Dave, good to be with you.
Thank you for joining us today. So, Michael and I were talking about what Cisco calls the fast lane for iOS. And it was kind of an interesting conversation, and then I got all confused, and so I realized I wanted to take notes, and then I realized maybe we should share this. So I asked Michael to join in this video cast to explain it to me once again a little slower. Just for a little background, it was about, I guess, just over a year ago. I don't remember when it was announced, Michael.
2015.
What was it?
2015.
2015, when Cisco and Apple announced a strategic partnership. They really wouldn't reveal what it was about. And we actually had a UC Strategies podcast on it. We were trying to figure out, are they really going to do something proprietary or not? And it finally developed or came to market. When did it come to market? About 6 months ago?
Yes, just about then.
About 6 months ago. Cisco calls it the fast lane. It is, I believe, I'll let Michael go here in just a minute, but I believe it's proprietary to the Cisco wireless access devices. And it's not limited to Cisco applications. Basically, any type of application could support this technology. Is that correct?
That's correct. Any application running on iOS, so any iPad or iPhone application.
Excellent. And so that obviously raises the question, which I know we're going to get to here in a minute. What about the Android users, and what is actually going on here? And is this marketing fluff or is it real? So when I was confused about this, I turned to Michael, who just confused me more. So we're going to put all of that behind us now, and we're going to clear this all up. So I just want to give you a little bit of a hook before I turn it over to Michael. One of his things that really caught my attention was it's actually fast lane for Android users. So I'll let Michael explain this one. So go ahead, Michael. You got some slides you want to share, or what were you going to do here?
Actually, this is one of the topics we're going to be covering in a session I'll be doing with Brent Kelly, Enterprise Connect, called Optimize Apple in Your Enterprise. So this is a little teaser for the Enterprise Connect session. But you're right, it did begin with the Cisco-Apple alliance, was announced in mid-2015. Here we have Messrs. Cook and Chambers at the announcement. And it was really two different things. It covers two areas. One is fast roaming. And the second is this business of a fast lane, which is basically a mechanism for prioritizing some applications over others. And they kind of got it half right. Now, first off, the fast roaming has been a challenge for us in Wi-Fi for years. I remember talking to the folks at SpectraLink about this over 10 years ago.
No, I want to stop you right here, because when I think of roaming, obviously I think of cellular roaming. And so the same concept generally applies to Wi-Fi, where you effectively move between access points. Is that what you're describing?
Absolutely. And you will roam, if you're moving, you'll roam a lot more frequently in a Wi-Fi environment. You can walk across the diameter of an access point coverage area in about 30 seconds. Nice. So if you're moving, you'll be handing off quite regularly. And we've had countless problems with devices failing to release from an earlier access point. The call drops, despite the fact that we've had standards for this for some time. And basically, for the fast roaming, what Cisco and Apple have done is standardize the implementation of existing 802.11 standards, particularly 802.11r, which is the roaming standard, K and V.
Now, hold on a second. I want to clarify, because I believe some vendors have looked at the roaming issue, years ago. So the issue was that it was not a standard; it was a proprietary implementation that some vendors had within their products. Is that?
Yes. Well, we initially had proprietary roaming capabilities among centrally controlled wireless LANs. We then advanced to the point where we had a standard. However, there was no industry-wide agreement as to how the standard would be implemented. So the first point to stress with regard to the Cisco Apple implementation is that it's not proprietary. This is all based on published standards. They just sat down and agreed about how they would do it. And hopefully all the details will be published. This could be a big boost for voice over Wi-Fi. And again, a problem that has plagued us for years. So the fast roaming part of this, there they really hit it right on the screws. The problem came up with the fast lane. Now, basically, the idea of the fast lane was a way of prioritizing traffic from certain applications over others when running on a Cisco infrastructure. Now, the idea just didn't make sense to me when I first heard it, primarily because why would we want to prioritize stuff based on the type of device it's coming from? We would prioritize it based on application. But basically what it does is provide a way of prioritizing selected applications. And essentially what Cisco and Apple did was implemented, the things that plagued us in layered protocols, layer-to-layer communications. So the thing is that for Wi-Fi, the priority will have to be assigned at the physical layer, on the Wi-Fi chipset itself. But up to this point, there's been no way for the application, the layer 7, to tell layer 1 and layer 2 how it would like traffic prioritized. So basically what they've done is implemented layer-to-layer communications. Okay. And the networking will respond to these priorities. Of course, there is a gotcha in this. It does require a mobile device management system or enterprise mobility management system that network administrators can use to assign those priorities. Unfortunately, though, it seems they've become a victim of the law of unintended consequences. And it gets down to some of the technology that's used to implement this. Now,
so hold on a second. Before you get to the technology, so they really implemented or created, did they create a standard or did they implement to a standard? Or in other words, is this something that Cisco and Apple created for the industry or created for just those two companies?
Well, basically, it will work. Any device can work with this as long as it implements the priorities the way they are defined. Well, basically the same way they are implemented by Apple. So as long as the frames are marked appropriately, the Cisco infrastructure will respond to that. But no one else we've seen to this point has come up with that way of ensuring the hard and fast communication from the application layer down to the layer 1, layer 2, basically the layers that Wi-Fi lives at.
Okay, so one more clarification here. So I understand Cisco's piece as the networking vendor. I'm a little confused about Apple's piece as the iOS and iPhone vendor. Is this something that is at the operating system level or the application level? And if an Android vendor or if Cisco wanted to implement the same thing on their Android client of their products, would do that? It would be operating system level. So it would have to be the Android device manufacturer, much the way Apple is the iOS device manufacturer. It would have to be the Android device manufacturer would have to implement this capability. Okay.
So it would have to respond to the same MDM commands that the Apple devices do, and ensure that the network requirements that are known at layer 7 are passed down to layer 2, so the correct priority is applied. But now some of the problems we run into. The first is we have a different number of priority levels at each one of the layers that implements this. Layer 3, DSCP, Div Server Control Point, is a 6-bit priority indicator, which would give you 64 levels. Most of those are never used. Now, at a wired layer 2, 802.1p, we have a 3-bit priority indicator, so you can get 8 levels. They cheaped out when we got to Wi-Fi. We only have 4 layers, 4 levels of priority. And that's where the unintended consequence came into play. Now, first, a little background on how 802.11 actually works. It is a contention protocol. Everyone's vying for access to the same channel. And to minimize collisions, what the protocol specifies is before a station transmits, it has to wait a period called interframe spacing to see if the channel is idle for that long before it attempts to transmit. Now, that's the mechanism that they worked with to implement 802.11e. 802.11e, the implementation from the Wi-Fi Alliance is called Wi-Fi Multimedia, so you see those two terms used interchangeably. See, what the 802.11e standard does is define different waiting intervals for different priority classes. I refer to this as the New Yorker's approach to waiting in line. You cut to the front. So basically, they defined a shorter waiting interval for voice traffic than they did for data traffic.
Okay.
If there's two stations waiting to send, one guy wants to send a voice frame, one guy wants to send a data frame, voice guy's always going to go first. Now, the four levels they define, this is where the trouble comes in. They're called ACVO, which is for voice, ACVI for video, AC best effort for best effort data, and ACBK, which is background data. Now, originally in 802.11, there was only one priority. All frames hit the median with the same probability of success. With 802.11e, the way things lined up is what is best effort data, ACBE, is the same waiting interval that we had for the original 802.11. What they did was they set one lower priority, that's background data, and two higher priorities, voice and video. Now, let's just look at the two for data. See, voice and video priorities, we've had those before, and basically that's part of what the Apple and Cisco are implementing along with fast roaming for better voice and video support in the Wi-Fi network. Trouble number two comes for data applications, however. So you only have two access categories for data. And the Apple device now is smart enough, based on the settings that are, or the priorities that are assigned by the network administrators, to say, okay, I've got this yo-yo doing Facebook. That's a low priority application. We'll mark that one for background data. This other more important application, however, we'll send that for best effort data. So they have two. The trouble with this is, an Android device isn't going to pay attention to that distinction. He doesn't realize that there's well, basically, the Android device typically will set voice and video frames to the higher priority if that capability is available in the particular Android implementation. However,
all Android apps are basically forced down the fast lane.
Correct. So at the end of the day, what appears Cisco has done is, rather than implementing a fast lane, what they're doing is deprioritizing some data traffic from iOS devices. But Android doesn't know anything about that, so all data traffic from the Android device will be sent at the higher priority. Basically, will be sent to the fast lane.
So this is really interesting. So if you were the mastermind behind Android over at Google, would you say, hey, we want to be part of this and we're going to embrace the same standard? Or would you say, hey, this is great?
Well, I mean, they could use it as a selling feature. So they'd probably be better off just to keep it. But the idea in theory is great. That we can have two different, well, we already have a voice and video priority. I didn't think that was going to ring.
Uh-oh.
Yeah, it's ringing like crazy here.
There you go.
Invariably.
It's Google calling. You know, they want to talk to you about this.
If a phone rings at the wrong time, it's my wife calling. Okay, I think I've turned off every ringer here now.
You realize we're recording this. She's going to hear that because I know she listens to everything I post.
No, she never listens to me. I don't have to worry about that at all. But theoretically, it's a good idea. Unfortunately, in order for it to work effectively, everyone has to be playing the same game.
I mean, that's really effectively the way all priority systems work, because you can't speed up things necessarily. You slow down other things. And so,
it's the joke we always use about quality of service. By definition, if you're pushing somebody to the front of the line, you're pushing somebody else to the back.
That's right, yeah.
So it doesn't seem this. So end of the day, I give them a B minus.
Now, B minus, but to be fair, they probably couldn't have done an A. I mean, I'm not sure what the better solution could have been. Now is this if another vendor embraces this, they're not going to call it fast lane. They're not going to. If another wireless vendor embraces this, what would be something that people should look for to figure out if it's the same thing?
A reference to Cisco's fast lane.
Because Cisco. Okay, so I was expecting you to say 802.11. Was it R?
802.11e is the quality of service standard.
What was the R? There's like an R for, that's the roaming okay, because I thought that was more or less a standard that other vendors could support, but that's a little different.
Yes, they can, but again, the problem we faced with 802.11r was the industry did not coalesce around a single way of implementing it. So, for example, things like opportunistic key caching. What a great name. What that does, in essence, is if a device is operating off a particular access point, what it will do is get an encryption key from all of the surrounding access points. See, if somebody's going to roam, we don't know which way they're going to go. And one of the things that has slowed down the roaming process before is, okay, he's going to this access point. Now we have to negotiate a new encryption key, and the call could drop before that process was completed. So opportunistic key caching says, I'll just collect keys from all the surrounding access points, so regardless of which way this guy takes off, I'll be able to track him.
Well, why is this such a complicated issue? Because roaming has been around on the cellular side for years, and that's much slower technology than local area wide area networks. And so why can't what's going on here? What's the delay factor?
Wi-Fi wasn't designed for voice. This is, I mean, the original name for Wi-Fi was WECA, the Wireless Ethernet Compatibility Alliance. They were thinking only of data traffic, and you don't see people walking down the hallway with a laptop balanced on their arm checking their email. If you're using a laptop, which was the original assumption for Wi-Fi, you assume the party's going to be sitting down. In the cellular industry, on the other hand, from day one, they realized the big benefit of this was the ability. I mean, the whole idea behind a cellular network is the ability for a station to roam from base station to base station to base station as the user moves along. So in essence, roaming was an afterthought in Wi-Fi. Where the cellular network, they knew this was a core requirement coming out of the gate. Huh?
Okay. Well, that definitely clarifies what I was confused about. And we're going to have to get you back on for another conversation around call kit, which is another confusing topic to me. But we'll save that one for a different time. Is there anything else you wanted to share before we wrap up, or?
No, that was it. We'll just switch back to the pictures. But it is a challenging subject, and it's important in dealing with these technologies. You do have a clear idea of what you're getting.
Yeah.
And certainly if and still today, voice over Wi-Fi is on the leading edge. And there are some significant, it's interesting you hit on the difference in terms of roaming. There are other tricks as well. For example, given the cellular networks have far lower data capacity than we have in a Wi-Fi network, they go to much greater lengths to ensure that data capacity is used more efficiently. I mean, Wi-Fi, you generally, your practical throughput, and this half duplex throughput, is about 60% of the stated line rate. So there's all this waiting, and every frame has to be acknowledged. All that stuff eats up into your usable data capacity. So it's a tricky business to work in.
Yeah, you know what surprises me a little bit, and I guess it shouldn't surprise me too much, but so much of the enterprise right now is about consumerization. In fact, the whole iPhone thing is about consumerization, right? Mm-hmm. And particularly things like unified communications. We're talking a lot about remote workers and workers at home. Meanwhile, on the home Wi-Fi front, we're seeing all these multi-radio solutions that you can spread out through your whole home or a small office for that matter. And so it seems to me that there's a pretty big opportunity for small business and home office, SOHO, I guess they call it. And this is ignoring that because they're not going to have MDM. And they're probably not going to have, the IT managers to set this all up. There's nothing really built in yet that's addressing the smaller end of the market.
Well, it's funny. The one thing that might actually help a lot of this in the Wi-Fi space is the cellular industry, because the cellular guys now are looking at rolling calls off onto Wi-Fi. And they know what the problems are in doing roaming. So potentially the fact that the cellular guys are finally picking up on Wi-Fi, and of course it's primarily out of desperation. They've spent tens of billions of dollars on licensed spectrum and still can't keep up with the growth. So there's a lot of different pieces in play. One of which now that we're watching very closely is LTE unlicensed, where the cellular operators want to use the 5 gigahertz unlicensed frequencies and basically intersperse that with Wi-Fi traffic, which is clearly going to have an impact on the capacity we have available in 5 gigahertz for traditional Wi-Fi use. So there's a lot of pushing and shoving going on in the wireless space right now.
Yeah. Well, very good, Michael. Thank you for taking the time, and good luck with that session. And your session is going to be a little more thorough and more encompassing, I'm sure.
Covering call kit, the challenges for Apple support, where Apple excels, the difficulties you can anticipate.
All right. We're out of time, Michael. But okay. Well, very good. Again, thank you very much, and we'll be in touch.